Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Rixson Duo Chek floor closer. Rixson has four models or four versions. They've got one Duo Chek. They've got four variants of it. This is the number 10 variant, which means that it is for doors up to 2'10" by 7 foot, and it is hold open. The 10 and the 12 are for up to 2'10", The 15 and the 16 will get you up to a bigger door, maybe 3'4", 7'0". It has a stiffer spring inside of it. And the 10 is a hold open. 12 is probably non-hold open. We'll take a look at that. We're going to start with just a visual tour of the item. It is September of 2022. This closer, the Duo Cheks, have been discontinued. And, you know, I don't sell them very often because this is material that you'll see very commonly installed in a mid-20th century home or earlier, or a variation of the 10, or maybe the Rixson Jr. Spending $1,000 on a double-acting floor closer in a home these days, I think, is likely far less common than it would have been 80 years ago, is the bottom line. So we don't see a lot of these. What I see when I see a Duo Chek is someone who has one and they want to get it repaired. I actually have one coming in to us now from a client in Chicago who's got a 10. The home is probably from the 1940s or thereabout and needs to be repaired. And the idea is, if we can't repair it, we do have one new one. Right now I have, by the time you're seeing this video, the inventory will obviously be different, or zero. A couple of maybe 2 12s, two 10s, a 12, a 2 10s, a 12, a 15, and 2 16s. I think I've got 6 left on the shelf. So let's just start with a visual tour. So here's the business end, obviously, of the closer. Closers like this, basically all closers, it is a mechanical action that compresses a spring. And when that mechanical action is the force put onto the door, creating that mechanical movement, compresses the spring. And when that force is removed, the spring will relax. What controls the rate of the spring relaxing will be fluid on the inside of the unit. And closers like this, and surface closers, and every other kind, overhead concealed, they all work on the same principle. And its variations on that theme is really what the bottom line is. So we've got the floor closer body here. This is exactly what it looks like. Give you a couple of basic dimensional properties just for the sake of archiving that. Overall length looks like it's about 8.5 inch. Overall width of the body, just for the sake of giving it to you, about 3.5. The overall depth looks like it's about down to the bottom of the boss, about 3 inch. The width of the plate, or the face of it, about 4 5/16 by about 4.5. That's the closer body. All of it, the entire closer weighs about 16.65 pounds. There is a cement case that is here. Okay, that is the cement case. The closer is going to literally fit inside of the cement case. It'll look reasonably like that. And it is literally called a cement case because these are meant to be put down into a bed of mortar, concrete mix. Let's work our way up. We're going to, well, for working our way up, you'll have the floor plate. It's going to sit like that. It's going to attach down to the body. Right there, you'll have that access hole for controlling the rate of close. This is in the 626 finish. Rixson, it wouldn't have said Asa Abloy decades ago, but it would have said Duo or Duo Chek, something like that. So if it says Duo, then you've got a Duo closer. If your closer is older than Duo, I think it would be a Junior. Those have become practically impossible for us to repair. We don't have any parts. Here's your bottom arm. That's going to obviously fit onto the spindle. That'll get tapped down. Once it's attached, that's going to allow you to make that door work in double act. Moving our way up the door, we're going to have the door portion of the top pivot. About 5 7/8 length. The bottom arm, overall length, about 9 inch. You'll have the scalp plate that's going to go on the header portion of the top pivot, about 6 3/4 by about 1 1/4 inches. And then you'll have the header portion. This is what's called a walking beam pivot, and right now the pivot pin is extended, and it's going to fit into the top of the door just like that. That's how that's going to work. How these walking beam pivots work is there's a screw that's here, as you can see in my fingernail is not going to act as a strong enough, and that's very dangerous what I'm doing. I won't do that. I would need a slotted screwdriver, which I don't have one at my disposal. When you turn that screw, it's going to bring that pin up and down, is what's going to happen. It just needed a little motivation. When I unthread that, the point is you should be able to see the top pin coming up. There we go. Okay, so when you install this unit, you're going to, once everything's attached to the door, you'll place it down onto the bottom spindle, tip it into place, run that screw clockwise to drop your pin down, and then it'll lock into the arm. Okay. Now, if you have a version that does not have this screw, let me back up. You can have a version that does not have that screw. There will be an access hole. From what I understand, that access hole, well, from what I know, that access hole is where you will insert a flat-bladed tool like a slotted screwdriver, and you're going to push a lever up. You push this lever up is what happens. You push it up, and that's how you'll retract that. So if you can't see any way to get all that to retract the pin, there's going to be a hole that you'll stick a screwdriver up there. Occasionally I've had customers say, yeah, I get it, I understand, I know what I can see what I need to do, but boy, I pushed on it really hard and it doesn't move. Push harder. Occasionally they said, yeah, that worked. It took a lot of force, but I was able to lift it. Once in a while, someone says, listen, I can push hard, it's not moving. So then we get a Sawzall and cut that pin off, is what you have to do. And that's really when you're replacing, when you need to get the closer off for it to be rebuilt, repaired, or replaced by us, and you can't get the top pivot to cooperate, cut it, you'll have to buy a new top pivot. Very, very likely remortise the door and frame as well. The face plate that's here, I don't remember if I gave you dimensions, about 8 7/8 and about 4 7/16. The only thing that will be left will be all of your fasteners, and I think I should be able to go through these. Whoops. What do you mean you didn't get both screws? Okay, I know what that's for. Okay. This is a bolt that's going to allow you to secure the bottom, the arm, which is the bottom part, to the door itself. Everything here. You won't use everything here. You'll use the machine or the wood screw. You will get those 2 screws. Those are for the scalp plate of the top pivot up in the header. These screws are for the finish plate down to the body. These screws are fun. The rest of these bolts are for the top pivot, to get the top pivot attached to the door and then to the underside of the header. Now these screws are fun. When you have an aluminum door, or you have an arm that is attached at one point, the nature of this arm needs to be absolutely parallel or perpendicular to the face of the wall generally. You'll have a large screw and a washer, a countersunk washer here. I think they're countersunk. Yeah, they are. That's what they look like. Okay. From on the face of the door, in an elevation perspective, you'll drill a hole for a screw with a washer on one side, and then on the opposite side, because there, from either side of the door, you can tighten and loosen those screws in concert so that you can take the door and cant it, skew it, bias it, half a degree this way, a 2 degree this way, whatever is needed, because you may have a situation where this is not absolutely in the alignment that you need it to be in. So you might need to take the door and cant, tip it this way, skew it, bias it, whatever word you want to use. And that's what those 2 screws, those adjusting screws, do. Very typical and very common. Aluminum storefront will have that stuff. Okay, so we've talked about the parts that are in the box. We've taken some basic dimensional properties. Let's now talk about what it's used for. Why are you looking at this, and in what application? If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So what are you going to use a floor closer like this from Rixson or maybe any other company? My grandparents' home was built during World War II. It was fairly new when my grandfather and his brother, my Uncle Junior, one went to the Pacific, one went to Europe, one went to the Pacific. And that home was built during World War II. I remember that home in the late 1970s, and it had a double-acting door between the kitchen and the dining room. Now, it wasn't a Rixson floor closer, but it happened to be a Bomber 7800 series horizontal spring pivot. And the fact that it wasn't Rixson doesn't really matter, but it's that application where you see these all the time. Most absolutely in older cities, or cities that are larger, and larger because they're probably older. And this was literally Chicago, the city of Chicago, not a suburb, near North Avenue and Oak Park, near North Avenue and Oak Park, a brick home. And when someone calls me, they have exactly a home like my great-grandparents, where it's kitchen to dining room all the time. That's where I always see this. I have a Rixson catalog from 1920. There's going to be a floor closer in there, and I'm going to show it to you. So these closers go back decades, in fact, over 100 years. Our record for a floor closer, repairing it, is 1904. May have been a junior, I don't recall. So pushing 120 years old at this point. It went back to the customer 3 or 4 years ago, maybe 6 years ago. It'll last another century. Because when we're rebuilding these, repairing these, we're using modern material science as well. So it's that application. Now this will be residential in nature because it's only for doors up to 125 pounds. And typical commercial doors are going to exceed that. The engineering on this tells us up to 2'10". They've stopped short of saying 3 foot. If you need a 3-footer, you'll go to a Model 15, or you would have gone to a Model 15. And that's where I see these. So very elegant, concealed option to make a door self-closing and double-acting and hydraulic in nature. So that Bomber 7800 I mentioned earlier, my great-grandparents' home, that door is just a spring. When you open it up, an eccentric lobe is going to force its really a cam and a bird's mouth principle, where when it rotates, it'll compress that spring, and the spring will come back and push the door. With hydraulic control, okay, the spring wants to move. Wham! Well, the oil says, let's slow that down. and you can adjust that. So that's what separates something like a Rixson Duo Chek from, or other manufacturers of floor closers, from anything spring based. There's a spring inside of there, but there's no hydraulic fluid in a Bomber 7800. So that's what will absolutely set that apart. Rather than the door just click, 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 coming to close, which it doesn't make that much noise, but it's audible. Fluid, the only thing you're going to hear inside of here is, if you got your ear close enough to it, you will hear fluid moving inside of the cylinder body itself. So an elegant way to go about doing it. We do sell floor closers for residential applications. It does happen. We obviously sell floor closers mostly in commercial applications where the weight of the door necessitates a floor closer, and it's because not only is this closing the door, but it's hanging the door. All of the weight of the door is borne through that arm, through the arm, onto the body, in the cement case that's been poured in grout, which is sitting on terra firma, something solid. So all of the weight of the door is right down in here, whereas with a double-acting spring pivot, yeah, that's accurate to say as well. But if you were to have a overhead concealed closer and it was independently hung, meaning hinges or pivots, 70% of the weight of the door is hung on that top hinge. So it's not as efficient of a way to hang the weight of the door. The point being is floor closers are used because they're concealed, but I would say that that's more of a side effect or a benefit, possibly a benefit, of using a floor closer. What will make you use a floor closer is likely the weight of the door or the design requirement where you can't see it. If you've walked into an Apple store ever in your life, even if you are Android all the way, notice the floor closers on those Herculite glass doors. Those are generally Dorma floor closers every single time. I'm going to imagine it's absolutely the weight of those 3/4 inch giant pieces of glass door. But the design aesthetic forces you to have a closer that can actually work with that. They need to be self-closing. And a floor closer does that. You can have patch fittings and then a floor closer into the floor. You can't have a surface-mounted closer on a glass transom and a glass door. I don't see that happening. So floor closers are used generally because the requirements of the opening force it to happen by either weight or design aesthetic. They just happen to be extremely elegant at both. So here's the problem. I've got a really heavy door and my architect doesn't want to see the hardware. Great, because I have a piece of hardware that was meant to hang a heavy door and not be seen. So it's perfect. So that's really where you'll see the world of floor closers. I have heard many times from Canadian counterparts of mine when I'm in Canada for classes, they don't use Rixson floor closers because the viscosity of the oil, those things never work right, the whole 9 yards. Just coincidentally, 2 weeks ago, I was at the repair shop where the closers get sent to be repaired, and we discussed that exact complaint. Outdated information, it turns out. The oil that was used in closers decades ago was not oil. It was something else. I forget what it was called. The fluid that goes back into a rebuild is a multi-viscosity type of application in the sense that it can hold its viscosity in an extreme wide range of temperatures. So the logic that a closer installed in Canada because of the cold weather doesn't work, that's probably quite dated data, would be my guess. Now, I'm not going to argue with people who live and make a living there, but, the front doors of City Hall in Chicago, the McCormick Convention Center, these places are full of Rixson closers. Like they receive them by the skid load. Lots of these are in exterior applications. They work. If you remember the Blues Brothers movie at the very end when they're running into the big giant building, well, that's Chicago City Hall. They go through some brass doors. Those doors are hung on Rixson closers. Those are outside. Chicago is known for about 10 weeks of good weather a year. It's also known for about 6 months of less than good weather, and 4 of them can be positively frigid. And those closers seem to survive just fine. So The point being is the weather shouldn't be an absolute issue for that. So floor closers are meant to solve these problems. The Duo Chek series is for residential, lighter weight doors. Now, I think what I'd like to do is let's move to the screen view. Let's look at all the supporting information. We're going to go through all the documents, and I'll touch on the installation aspect. Installing these are conceptually very easy. From a labor perspective, they do take labor and time. It's basically, there's got to be a prep in the floor. That cement case has to go in. The closer body has to go in. It has to be leveled off in all directions. It has to be placed so that the plumb line coming down from the top pivot is absolutely spot on. That all has to set. The header's got to be prepped. The top of the door's got to be prepped. The bottom of the door's got to be prepped at a specific location over from the jamb. And once you've got all that done, you're going to have decades of reliable, dependable, predictable service. Let's switch to the screen view now. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. All right, let's talk about this hardware. This is the label on a box, double-acting closer, LAP, less all parts. This is the box the body was in. Actually, the body in the cement case. Oh, no, that's wrong. Just the body only. Rixson 10. It's an A because the 10 is an automatic HO, hold open. Auto HO, automatic hold open AHO. There's everything in the box. Now, we're going to talk about this cover here. I don't... It's meant to go there. There's no doubt. But I don't know why that cover plate is loose. I don't know the function or reason for that. We're going to find out why. Maybe if I can't answer it through this video, I'll get the answer. Closure body, bottom arm, instructions, cement case, screw package, cover plate. This would have been available in lots of different finishes. Your brasses, your bronze, your brasses, your chromes, your nickels, your powder coateds, your oil rubbed. Top pivot assembly and scalp plate. Closer body itself. I'm going to go with the month and the year that this was manufactured. 12/21. That adjusting screw is there. Telling us it's a 10. I don't know what that means, although we'll take a look at a document that I have. Other perspectives on the cast body itself. That is a tapped hole. I'm going to go with there's a screw and a washer for that once the arm sits onto it. All right, let's look at some additional photos. Side view of the spindle. The opposite end of the, that's where the spring's going to sit, reside. That probably threads off would be my guess. Should only be threaded off by someone who knows their way around these closers. Top pivot assembly, header, door, scalp plate. Another perspective on that. The underside of the header portion. The door portion. Another perspective of that. The underside of it. The scalp plate. That's 626 finish. The two screws for holding it on here and here. Your top spindle and then the walking beam adjusting screw. Your bottom arm that is shown how it would sit on top of the closer. Another perspective on that. The underside of it. A stamping that's on there or numbers cast into it. I don't know what those mean exactly. You know, manufacturing lot number, that kind of thing. Those are the screws that will allow you to tip that door in and out or cant it in and out. Last set of photographs. Here's the cement case. with the closer sitting in it. Your floor plate, again, your fastener package, and your installation instructions. Now, documents that are posted down below in no particular order. This would be called a parts drawing. I found out that this was discontinued because the client ordered from us a repair service or an exchange service. Turns out we didn't have any repaired units or rebuilt units. And he says, well, what about a... Actually, no, the client had a junior. And turns out can't repair those. But we have successfully had clients in the past remove a junior and install a duo, and reworking of the floor required, but nonetheless, that's what this client elected to do. So I went to the factory to order a duo for the client, find out that they're discontinued. So I went through wholesale and snapped up all that existed. Oh, J. Yeah, okay, well, J is the, yeah. Looking for evidence of why that cap is loose on the end. Okay, just, your top pivot, letters, working with a client in Iowa who had the F alignment screws and washers removed from his wooden door. It needed just those. All the parts are listed here, self-explanatory. The next document. These are installation instructions. Okay, let's get past that. Let's just do the easy ones first. The how to order. You're not going to be ordering this, but nonetheless, this would have shown you how these part numbers would have been built. So you've got a 10, 12, 15, and 16. You could have done a physically handicapped version of the 10 and 12 where it's even a lighter spring that's inside of there for a reduced opening force. You can do a hold open or non-hold open. You could have ordered them with extended spindles, and I'll show you that in the product catalog. Absolutely not for fire-rated applications. I'm not aware of any center-hung products that are fire-rated. Not handed because they're double-acting. Then it tells us the maximum door weight over here. That is a template. We'll come back to that. Here's a cut sheet. We've got the 10 and the 12 here, and then the 15 and the 16. So the 10 and the 12, double-acting, non-handed, low, medium traffic interior doors, up to 125 pounds, 210 by 70. That's what we're looking at here. The 10 is an automatic hold open. The 12 is a non-hold open. That's your part number for your standard top pivot. Not allowed on fire doors. Cast iron cement case, adjustable closing speed. That hole right there. Centering arm for adjustment. That's those arm adjusting screws. 95-degree maximum, 1.75" door thickness. You can use it on a thicker door. You're just going to have to you're going to have to determine where to locate everything based on the door thickness. That dimension from the jamb, which is 2 inch, to the vertical center line is going to need to get looked at depending on your door thickness. You'll see that it refers to a radiused edge here. Furnished with wood and machine screws. Spindles could have gone from up to 2 inch and 1/2 inch increments. Why would you need an extended spindle? Well, first of all, you've got your door and you've got your floor. Provided the clearance, the bottom of the door to your floor, is such that you don't require a longer spindle, you're good. If you have an excessive undercut here, you're going to probably need a longer spindle, or there might be an application with floor closers in general where the floor has been poured, concrete. The floor closer body, or the cement case at least, has to go in because they're then going to pour additional flooring over that. Or, more likely, they're going to put a terrazzo floor in. So your closer body is really going to sit like here. And then your flooring is going to come in. Actually, your flooring is going to come in and do this. So when you have an application like this, you will need a longer spindle. But understanding what you're going to need is easy when we look at the template. The 10 and the 12 were able to meet the low closing 5 pounds of force when you would have ordered the PH version. The 15 and 16 are identical, except they'll go up to a 3/6 door. Same door weight, however. It has a stronger spring to accommodate the wider door. 15, hold open, 16, non-hold open. You could not do physically handicapped because it's, you're not going to reduce the spring when you're looking for a model with a stiffer spring. This is the product brochure. This is out of their specialty closers. This, I think, is out of the 2018 catalog, because in the 2022 specialty closer product catalog, the duo checks are not in there anymore. They have been pulled. So they are in here, but basically the documents that we just went over are the documents out of the product brochure that pertain to what we're working on. So that's there for your review. So let's look at the template first, and then we'll go to the installation instructions. When you have this template, you really don't need installation instructions, in the sense that you do, but I wouldn't, because everything that you need is on the template itself. Although having installation instructions, of course, are always the first thing that we read before we start installing something. So study of this document is mandatory the first time that you see this. So when I look at this stuff, having machine doors in the past, I'm studying the document for the data that I know that I need, which is, where do I put this? Where does this go on the door? Where does this go on the floor? So when I see this, I'm looking for, okay, how far over from the jamb is my vertical axis of pivoting? That's my reference point. It happens to be 2 inch. You can also see that it's 1 7/8 from the edge of the door. Well, okay, well that tells me the edge of the door to the jamb is 1/8 of an inch. Now I know what my net door width can be based on my finished opening width. 1/8 inch on either side. That gives me a lot of data. That could be what you're looking for first. What do I trim my door to? So let's just look at that first. Well, let's say it's a 3/0 opening. You'll make it 35 3/4. They are telling you that it's radiused. That's obvious. 1 7/8 radius is your max. You're going to need a large bullnose bit for this. They make them. I'm sorry, a radius bit. If you're doing single acting, you would just bullnose it. So it's called a roundover bit. I think I have a 2 1/4. Well, I don't remember what I have. Might be 1 3/4. I haven't used it in a while. Here's a 2 inch radius roundover bit. So you'll need a roundover bit, and prepping the door for a roundover, to do a roundover radius edge, which is just a bullnose on either face, is what we're really talking about. So you'll need to do that. Now you don't need to do that. You can leave it square edge, but you're going to want to calculate how much room you need there. You're probably going to want to make that 3/16, depending on the door thickness. I use AutoCAD for figuring out what that is. If you don't have that luxury, or you've not exposed yourself to the pain of learning AutoCAD, then you're going to have to get the answer. Your distributor will be, should be able to provide. If they're making the sale, they should be able to get you that answer. So now I know my width. I'm either going to radius the door or leave it square edge. You're going to want to radius it to give you the tightest margin possible here. You could probably even get that closer to a 1/16 of an inch, although it's not suggested to make that so tight unnecessarily. So now the other question is, what height do I put all this at? I'm not seeing anything here. Aha, there's something about height. So you know you're going to have an 1/8 of an inch at the top of the door. The underside of the header to the top of the door, 1/8 of an inch. You're going to match what you do on the stiles, on the vertical edges. It's the undercut. Well, pardon me. It's the amount that you trim off the door to achieve a specific clearance is what you're really thinking about now. So, provide sufficient clearance between door and spindle shoulder collar. Okay. Yeah. Okay, so my door has got to be prepped in such a way that it will fit over the base of the closer body. 1 inch required. Okay, that doesn't really help me. Okay, door mortised, 1.1/8 deep for the arm. Okay, so if you've got a 3/16 clearance from the top of the closer, from your floor, the top of the closer to the underside of the door, you're going to mortise that 1.1/8 deep. That's great. But it tells us that your undercut, your total pre-fit height is going to be 5/16. So if you've got an 80-inch tall opening, you're going to make it 79 and 11/16 is what it'll be. Well, you might say, no, 3/16 will not work for me. I'm going to need to have a greater undercut there. Pardon me, a greater clearance. Undercut is the wrong word. A greater clearance because my floor's not level, or you're using a threshold. Now, what's very interesting about that is when you look over here, it shows you the relationship between your threshold height and the 3/16 and how deep you mortise the door. So as the threshold gets taller, your mortise depth gets shallower, and that makes sense when you think about it. So let's imagine you're not using a threshold. You just need 3/8 of an inch. You need 3/8 of an inch from the bottom of the door to the top of the closer body, not 3/16. You're going to simply adjust. You're going to make shallower your depth of how you mortise the bottom of the door for the arm. So long as you can get the arm installed to the bottom of the door and it's not projecting off of the bottom of the door, whatever clearance you're contending with, you're in good shape. This could also be a reason why you would need an extended spindle, because the door was built, the home was built during World War II. Then there was a flooring condition that changed sometime in the 70s, and then in the early 2000s it changed again. Or no, the shag carpeting went in, and then they trimmed all the doors, and then there was a problem, and then you made another change. The point of the matter is, having an extended spindle has everything to do with the flooring condition, or what's going to be done between the bottom of the door and the top of the floor where the closer is sitting. Whether that be a threshold, or terrazzo, or shag carpeting, or hardwood floor, or you just want an undercut sufficient enough to provide airflow. I've seen in construction documents, 1-inch undercut to provide airflow to the HVAC. Not that you would necessarily have that here, but what you're doing here is what's going to determine your net height. So we've gleaned out of our template what we need to know to cut our door, literally size our door. Okay, we pulled all that off this template. No installation instructions. We know we have to radius it, or we know we don't, but we know that we have to think about it. The next dimension I'm looking at when the rubber needs to meet the road is, where do I place the hardware? Let's do the bottom arm first, because that's how I would generally do it. We know that looking at this, that the arm itself is 9 inch in length. We know that the depth is determined here, what we're doing, our mortise depth. What we don't know is how wide of a prep we need to make that just yet. So we have our length, we have our depth, but how wide? Oh, we know, it's 1 inch. It says right here, 1 inch minimum required. It's right there. Now we got all that. Now you can take your router and prep that. I might be quite inclined to make that a little longer than 9 inch. I might make it 9 1/4. Ain't gonna matter. It's gonna be physically attached to the door in 3 places. So I'm going to prep my, 9-inch, 1.1 by 1 inch, but I have to locate it at 1 7/8 inches from the edge of the door. Now, that dimension is not from here over 2 inch. It's from here. So be mindful of that. 2 inch is where that's got to be. That's from the jam. I'm sorry. I said that wrong. What I was saying was from the jam. It's going to be 1 7/8 inches. 1 7/8 inches from here. The edge of the door, the high side of the door. Well, the actual width of the door, not where the radius terminates. So I know that it's going to be at 2 inch. Great, I can prep all of this. I can then move to the door portion. I know the vertical axis of pivoting is at 1 7/8 inches from the edge of the door. I know that my door portion is 5 9/32 plus 5/8. So 1 divided by 32 times 9 plus 5 plus 0.625. I know that I'm 5 and 29/32 overall length. Double check your math on the overall length, almost 6 inch. I know that it's 1 inch, and then I know my depth is going to be 1/4 inch, and I know it's going to be 7/8. I got that prep. You do the same in the header. You get where I'm going with all of this. Your jam portion, 6 3/4, 1 5/16, 1 7/16. That's what you'll make it all the way across. Everything at 1 7/8 inches from the top of the door. From the cased opening frame to the vertical axis of pivoting. At this point, you know exactly how to prep the door, not only for its net width and height, but how to prep for the hardware. Now, you need to get the thing installed, and the installation instructions are not going to tell you how to jackhammer concrete. But let's look at our notes. Don't scale, suitable reinforcing by others, set cement case a 1/16 below the surface of finished floor when you're using a floor plate. You may not be using a floor plate. You might have a threshold that sits over it. So be mindful of that. You might have a terrazzo pan that sits over it. Set cement case flush with finished floor when using a threshold. We'll set it, so flush when using a threshold. Maximum degree of opening, trim permitting 105 degree. Well, this is for 95 degree. What they're saying, though, is when the door gets pushed to, it's going to hit the jam when the door gets greater than 90, I think is what they're saying. Provide 5/8 diameter holes for alignment screws. That's down here. In the face of the door, they want you to drill a 5/8 hole in the face of the door in those locations. I don't see where off the bottom of the door that's to be drilled. Oh yeah, here it is. Yeah, right here. 15/16 to the center line. Then you can determine your horizontal dimension. All dimensions given in inches. Great. So let's look at what we call the installation instructions. Yeah, a lot of this is going to be the same baloney. Back when I first started playing with hardware like this, there were no installation instructions. It was the template. That's all you got. And I've just gone through the template, and that's all you actually need. Rixson is exceptional. Sargent is exceptional when it comes to their templates. They're sister companies, by the way. So there are 4 pages in these installation instructions. There's 2 pages in my PDF, but those are meant to be folded across each other. So page 1, 25% of it is a regurgitation of the template. Page 4, well, we'll get to page 4. Let's get over to page 2 now. What would be 2? Gives you a lot of detailed dimensional data on the closer body. Now, the first thing that's not, all of this could be a mention or a note on the template. You have to install the closer body absolutely plumb to where you've located the top pivot. The vertical axis of pivoting must be utterly plumb. Do not strike closer. Don't strike closer with a hammer. I'm imagining that at some point in the history of Rixson, some guy calls Rixson and says his closer is broken. How did that happen? I don't know. It worked yesterday. Well, what happened? Well, I think what was happening is that they were breaking up the floor because they had to replace a piece and accidentally hit it with a hammer. So don't strike the closer with a hammer. The closer cannot. The closer can be made completely inoperative by denting the closer tube with a hammer blow. So there's a reason that's there. Don't hit it with a hammer. Must be plumb. Locating the closer, we've done all that. This is nothing new for us. This, though, allows you to understand how you have to level that. Rixson, I believe, has a tool for helping you level floor closers, and it's basically, I believe, a metal apparatus that you attach down to the cement case where the closer will ultimately sit, so you can push it all down there and know that you're level in all directions. For floor plate application, the top of the closer case are at the same level. Set a 16th below if you're going to use the finish plate. Okay. Set flush if it's a threshold. Cement floor closer. The set cement case in floor and block in position. That is 9 words that doesn't begin to explain how important that is. Case should be parallel with center line of door. It should be, because that's how the door closer is going to sit. So here's the door. That cement case needs to be parallel. From here to here needs to be parallel on the door. But those adjusting screws are there for you to cheat a little bit. The cement case has to be level. They put that in capital letters. Place levels per illustration. That's the illustration. Grout in cement case with the closer. Cement should not get between closer and the case. Keep the cement out of the case. But when you pop all that down into the floor, the closer body's got to be in the cement case. Wood floor installation. Locate center line of closer 2-inch. We went over that. Okay, so using dimensioned outline of closer. Wood floor installation. Locate center line of closer 2-inch from the face of the frame. Using dimensioned outline of closer, locate and bore 8 3/4-inch diameter holes. Cut out the flooring using these bored holes and the dimensioned outline as a guide. Here it is. These are the 8 holes. I've never put this into a floor closer. I've never put this into a wood floor. So you're going to drill these 8 holes that they refer to and then jigsaw cut all of this together. And you'll drop that closer down. And I've seen these installed in wood floors. And I always said to myself, boy, that closer doesn't really sit flush at all. It's as if it's sitting on top of the floor. Place arm, so cut out floor using what we just showed. Place arm on spindle of closer and set closer into opening with center of arm on line with center of door. Draw line around overlapping square top casting. Mortise for this overlap. Okay, so they're telling you to mortise the wood floor itself all the way around the perimeter of that. Why the arm needs to be installed at that point? Maybe as a handle to get the closer out of the floor, I would imagine. Or off the floor. Who knows? Closer case should be level. Fasten closer securely with the screws furnished. There are... Yeah, there are 4 larger screws in here, and then there are the other screws for the top pivot. Place floor plate on closer, mark around it, and mortise into floor. Fasten with screws furnished. So yeah, you're going to cut the wood floor for this, and then you're going to mortise to get that square portion, rectangular portion of the closer itself, the body itself. Hang the door. Oh, wait a minute. That was page 2. Now we're going to page 3. Hang the door. So, at this point, the arm needs to be attached to the bottom of the door itself. Hold the phone. Hang the door. Uh-huh. Yeah, so let me digest something. So a couple of questions that I have. First of all, the 5/16 18 machine screw or the 3-inch long flathead wood screw. I don't know what the plan is for getting that turned in, except to use a very tiny right angle screwdriver. So that's the first problem that I see. They refer to it. It looks like the bushing's going to go into the bottom of the door, and then the bolt will go through the bottom of the arm. And I suppose if you can sneak a very small right angle screwdriver underneath there, you should be able to get that turned in. But you want to pre-drill the hole first. If it's a machine screw, it's no big deal. So, but that's going to have to go in before you hang the door. The bushing will have to be It appears to me that they're showing the bushing in the door itself. And they're telling you where that needs to be. Yeah. Well, to me it's looking like the door, the arm's going to be in here. Your spindle's going to be in here. There's going to be a dimension from here to here that you're going to have to pre-drill a hole for the bushing to sit into the arm like this. So this will sit on your arm is going to be here. Then that screw is going to come up from underneath here. And when you tighten that screw, it's going to draw the door down on top of that bushing. And the bushing is what just makes, the installation of everything tight. So I would think the hole's got to be pre-drilled. The bushing's got to be placed on the arm. But this doesn't make any sense. I don't see how that works. I don't see how you get a 3-inch screw up underneath there. And then there, yeah. That's how I'm saying to show the bushing. This is a little funny. This screw. There's, yeah, there's only one bushing in this package. Yeah, well, yeah. So that arm's going to have to go. Okay, I figured it out. What has to happen is this is drawn strangely. So what's really going to happen here is yeah. Okay. So yeah, I figured it out. So what needs to happen here is the bottom of your door is going to have to be, the bottom of the door is going to have the bushing and the bolt already installed. So it's going to be installed in the bottom of the door. The arm is going to be screwed down to the top of the closer body itself. You're going to drop the door onto the arm, which is attached to the closer body, by means of this screw here, and then set the door on top of it so that the bolt and its bushing will then nest inside of this hole. And it's not mechanically fastened. It's just the bush. It's so tight between the bushing and this hole, doesn't allow any movement. So that solves that problem. There's no screwing that you have to do. So that's how that's going to happen. Now the other issue that I am scratching my head on is the closer body is installed to the wood floor. It's level. You've got the floor plate attached. Turn valve screw down. The valve screw is the speed adjusting screw in here. Never force valve screw down, as this will damage tip seating. Okay. Fasten arm to closer spindle. Then turn spindle right or left until spindle and arm reach a door opening position of about 30 degrees. Okay. So what I'm thinking, they want you to close the valve and then rotate the unit to 30 degrees. I would think, and you'll have to test this, that I would get the door on top of the closer at the floor. I would engage the top pin. I would open it to 30 degrees, and then I would I would get the arm rotated to 30 degrees. I would then close the valve. At that point, I would set the door on top of it, drop the top pin down, install my alignment screws, which are the screws on the face of the door, which are here. I wouldn't try to cycle the door at all. At that point, I would hold the door. I would control it as I opened one turn counterclockwise, that speed controlling valve. That's how I would do that. I've never done it, but that's how I would do it. And before I closed the valve and then forced the closer to cycle, the door to cycle, I would call the factory and say, "Are you sure that A and B are on the right step?" I'm thinking that they're not. I'm not Rixson. I'm not a trained engineer on their products, but it seems to me that a closed valve is a closed valve and fluid won't move. So that is my take on the installation aspect, and it's also all of the supporting documentation that we have. There's a link below this video that is going to lead you to, right here, that will lead you to the manufacturer's page. And from here, you can pull up not only all of the Rixson products we sell by means of this horizontal navigation, but also a link to the manufacturer's website. Let's take a look. The manufacturer's website. as well as a link to the current full product catalog and prior versions of books, prior versions of catalogs. I have a 2010 product catalog. Rixson at one time made an an electric deadbolt, the 401 series. I've got data on that discontinued line. And we also have a catalog from 1920. That's awfully fun. When you click on that, it will open up that 1920 catalog. I bought this and then scanned it into the website. It is a large, unwieldy document, so you may want to save it to your desktop. And as you go through here, I mean, this is right after World War I. Olive knuckle hinges. A friction hinge. I would have to read. I'm not familiar with the term friction hinge. I get it. I can get an idea of what they're talking about. A casement operator. Cremone bolts. Concealed transom operator. The Chicago Public School I went to was built during World War I, and it had lots of transoms.
I found this on the web.
Stop it. There's a single acting door check. Potbelly door closer, we would have called that. Aha! A single acting floor closer. This is a number 20 and a 25. The 20 is an oldie but a goodie, that's for sure. Aha! Here we go. Check this out. There's your number 10. Double acting floor check for use on interior doors only. Isn't that cool? That's a number 10 from 100 years ago. It's got a different sort of design to it. This pin tells you all about that. But neat. There's a 30 and a 40. They still make the 30 and 40 floor closers today. Yeah, that's cool. So the number 10 shows up in a catalog from 1920. Yeah, they had the 10 or the 15. They had the light duty, the 2.8 and the 3.0 is what that is. That's really neat. We'll get that added to the website. Let's wrap up this video on camera. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, you know, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. So if you have any questions on the Rixson Duo Chek closers or any other Rixson floor closer, please feel free to reach out to us. Floor closers are a really great piece of hardware because they're capable of those heavyweight doors and decades of service. We just saw that they were in a catalog from 100 years ago. And the technical support department over at Rixson is really great. They're always very helpful. Everything that Rixson makes, you know, the saying that we have in this industry, we're not high tech, but we're highly technical. And there's a lot to know about a floor closer, as evidenced by a 30, 50-minute video on a single piece of hardware. Don't hesitate to reach out to us if you need any help with your stuff. Because of Rixson's lineage as an American manufacturer of hardware, they go back to the 19th century. You will encounter eventually their products if you are in the door hardware industry as an architect, a designer, a specifier, an engineer, a distributor, a manufacturer, an installer, a general contractor, a subcontractor. You know, if you're an auditor of fire doors, you'll see their products eventually. If you have need for something to be repaired, namely a floor closer is what we see most. I don't see Rixson pot bellies. I don't know that I ever have. Maybe one. And there are overhead concealed closers that we can repair those as well. So let us know. Any questions on this or any other Rixson product, please feel free to reach out to us. And thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you. Thanks to our clients, Architectural Builder Supply is building an additional facility, and what follows is not only a look at the acreage that we're building the facility on, but also first the architectural renderings as they exist, or at least the architectural plans as they exist at this time. Thank you very much. Let's take a look. All right, let's take a look at the architecturals as they exist at this moment, or at least it wouldn't be proper to call these architecturals, but it would be proper to call them renderings in the sense of they're conceptual drawings, they're not renderings. So the entire space is going to look like this in terms of a site rendering. This will be a 22,000 square foot building, of which we'll have specific purpose areas. There'll be a workshop down here. This is a few thousand square feet that will be likely woodworking, metalworking, CNC, things of that nature. This will be an office area here, a private office area. This will be Architectural Builders Supply expanded storage area where we will be able to do fulfillment. The entire space in the center is going to be all of the volume, as I call it. Large components will be able to be stored and stocked there. Machinery that's too large to fit otherwise may be put out here. Specific facility rooms, and then some recreation over here. Let's take a look at that drone footage, and thank you very much for taking a look.